Part 2, 5.2. Okay, we're kind of going to put a bunch of the stuff from part 1 together. So first thing for this A, we're going to factor because we have to find the zeros and we're going to sketch the graph. So for first factoring, what do these all have in common that I can take out? I can take out an x squared, leaving me with x squared minus 8 plus 16. Now looking at this, it's saying, okay, multiply to get 16, add to get negative 8. I forgot my x value. So I solve that x squared. This would be negative 4, negative 4. They multiply to get positive 16. They add together to get negative 8. Now I have to find my zeros. So x squared is equal to 0, and x minus 4 is equal to 0. If I take the square root of this, I have x equals 0. And then if I add this 4 over, I have x equals 4. Now, when I'm sketching this graph, I have to make sure to state the multiplicity. So this 2 here, because this 0 has 2 right here, that means this has a multiplicity of 2. When I look at x equals 4, there was 2 of them. I could have also written it like x minus 4 squared. That's a squared. This is the same thing, but that means that it has a multiplicity of 2. So now, a couple of things. I can add up my multiplicities and I get a degree of 4, okay? Degree of 4, there's no negative out in front. Degree of 4 means my end behavior is going to be up, up. The other thing now when I'm dealing with the graph, if I have a degree that's greater than 1, sometimes it's a little special. If you have an even multiplicity like this, I'm going to put a star there, and I'm going to put a star right here too, because if you have an even multiplicity, that means on the graph it hits that spot and turns around right away. So when I see a multiplicity of 2 or 4 or 6 or 8, something that's even, a multiplicity that's even, I'm going to first plot 0, so x equals 0, and I'm going to actually put a star right there. And then x equals 4, 1, 2, 3, 4. So here's my points, but then I'm going to also put a star right there. So it's starting up because my degree is 4. My end behavior is up, up. I'm starting up, and whenever I hit a star, turn around at some point, again, it doesn't matter about those turning points. I have to touch that star again and then turn around. So my end behavior is still up, up. What this is saying, when you look at a graph and if it touches the x-axis and then turns around right away, that means it has a multiplicity of an even number. That's what that means. So that's question A. I'm actually going to get a different color. So B, it's already factored for us. That's so great. So I have 2x plus 5 is equal to 0. So 2x equals, I'm going to subtract that 5 over and then divide by 2. Here I have x minus 3 is equal to 0. So x equals 3. So if I'm going to write my zeros over here, x equals negative 5 halves. That's a multiplicity of 1 because there's no number right here. So there'd be like a little 1 there. X equals 3 has a multiplicity of 2 because it's squared. That means it happens 2 times. This parentheses happens 2 times. So I'm going to put a star right there because I'm going to represent that on my graph. My degree here, if I add these two together, I have a degree of 3. It's odd. So remember, if it's odd, that means it's opposite. So down, up. So now I have all the information that I need to graph it. So first, I have negative 5 halves. That's the same thing as negative 2.5. So if I go 1, 2, 3, I'm going to put a point there. A point there because it's odd. So I'm going to go through that point. At 3, 1, 2, 3. Here's my point, my 0, but I'm going to put a star there so I remember. When I see a star, got to turn around. I start down. I should end up, up. So I start down. Whenever there's a point, you should go through that point. It doesn't matter where you turn. I have to still touch the star, so I have to come to the star, and then actually I have to turn around right away. It should not be a V. It should still be like a curve, but I ended up down, up. It does not matter where that curve ends up. So I could have also, this same thing, and both of these would be 100% correct if I started here and I went through this point and then I went really high up. and then touched, and then went over here. I would give you the same points if you did this. If I went here and then touched and then went up, all of those would get the same points as long as on this graph you go through the -5/2 and you touch at 3 and turn around. So C, looking at C, first thing I did was factor. I already factored it for us just so it wouldn't be as long. So my C, I could take out a 9x and then multiply to get -3, add together to get 0. So I have 9x equals 0. So if I divide that by 9, x equals 0. X plus 3 equals 0. So x equals -3. And x minus 3 equals 0. So x equals 3. So here are my zeros. This happened one time because there's not a squared. X equals -3 happened one time because there's only one x plus 3. And x equals 3 happened one time because there's only one x minus 3. My degree, 1, 2, 3 is 3. Odd. Odd is down, up. So when I sketch this, there is no stars. I'm seeing stars. I'm seeing stars. No, I'm not. I'm not seeing any stars. So I'm going to plot my point at 0. I'm going to plot my point at -3. 1, 2, 3. Again, these are points. And at 3. 1, 2, 3. I start down. So when you're looking at this graph, I start below the x-axis. That's what that means. Start down on the left-hand side of your points. Since these are all points, I go through them. I go right through. It doesn't matter where I turn. I just have to make sure to go through all the points. Since I already found out the end behavior was down, up, I should end up up. Sometimes the other thing you should check is your x-axis. You should only go through at your points. If I were to go through it in between here, that would be incorrect. Should only go through my x-axis at these 3 points, which you found. D, it's already factored for us. X minus 2 equals 0. X plus 7 equals 0. So x equals 2. X equals -7. X equals 2, that happened one time, so that has a multiplicity of 1. X equals -7, that happens 3 times. Ooh, this is a little bit different now. Just a little bit though. So when when I look for my degree, 1 plus 3 is 4. So it's even. So it's going to be up, up. So when I graph this, x equals 2, 1, 2, happens 1 point. I'm going to put a point there. -7, 1, 2, 3, 4, 5, 6, 7. I'm not going to put a star. I'm going to put a point, but I'm going to do this, kind of so I remember. Because when it is odd, if it's greater than 1 and it's odd, it should kind of just curve like this, like do a little, like just a pretend, like it should curve kind of like that. So I'm starting up, okay? So I'm starting up because it's up, up. Starting up here, I'm going to kind of go through this point. It shouldn't be a straight line, but a little curved. And then it doesn't matter where I turn around. And then this one for sure I have to go through. Now you're thinking, oh my gosh, Ms. Strickman, to me, those look like the exact same. I'm not going to be super, super picky when I see this, but you should try to remember that if it's kind of curved like this, it has an odd. Okay? I want you to try to do E and F. Pause and do E and F by yourself, please. For E, I have x equals 0 and x equals 8. This has a multiplicity of 2, so that happened, my degree here is 3. So it's down, up. When I graph it, I have 0 and 8. 1, 2, 3, 4, 5, 6, 7, 8. 2 points, but I'm going to put a star there. I'm starting down. I go through the points. I still have to touch the star, so I touch the star and turn around right away. So it looks something like that. For F, it's cubed, so it's down, up. So at 5, 1, 2, 3, 4, 5. I will be picky on this one since it's just the cube. You should have, I'm going to put a star like that. It should not be a straight line. If I see a straight line, that would be incorrect. It should have some sort of curve. So it's kind of like this. I would accept something so it's just curvy. It's not a straight line. Do not make a straight line. So still down, up, multiplicity of 3. And there we have it. All these beautiful graphs, part 2, 5.2. Have a wonderful day.